Hello, Ted.
Hi, we ready to get started?
Yep.
Ready. We are ready.
So I'd like to introduce Christian Browner and Alexei Sarai, who will be talking about extensible syscalls. Thank you all. All right.
Thank you. I'm Christian. This is Alexa.
Yep.
We do things, we work on the kernel, or we do things for the kernel, do things to the kernel, depending on how people see it. And we want to talk a bit about extensible syscalls, and this is meant to be sort of a discussion point on some new conventions we think might be useful, because we keep seeing people running into the same issues when the new syscall is sent to the mailing list, and it depends on who is reviewing them and what they have their eye on, what do they spot, and so on. And I think we could have a bit better, a little bit better conventions for that. Okay, let's see if this works. A bit slow, but you can see it, right, Alexa?
Yep. I mean, hopefully everyone else, including me, can see it, not just me and you. But
yes, but you're unmuted. That's why I asked you.
It's very seeable.
Good.
Okay. So Groundhog Day. We think it would be good if we had sort of an agreement on how we design future APIs. So not obviously not all the details, but just in broad strokes. And we seem to be having the same argument with each new API proposal that comes to the list, especially when it comes around syscalls. And depending on your personal point of view, some people start to argue we need to have a full-blown multiplexer that is so generic that it ideally spans multiple APIs at once, or individual syscalls for each operation to keep the API as simple as possible for the kernel. And with both approaches, we think we've burned user space and ourselves quite a bit already. And it seems to some extent there are no good guidelines to follow for developers. Well, there are some guidelines, but
not modern ones, at least.
Not modern ones. And so the idea is that we should have documented stronger requirements for newer syscalls. And sort of a baseline around the extensibility for new syscalls to avoid the whole issues around rename add, rename add to, read link add, dupe accept, and so on, that all have reversioned syscalls that have added a flag argument to be extensible. And what you want to talk about is something that we called extensible structs. And we want to make it very clear right from the start that we're not proposing that using structs and syscall is the new baseline for extensibility. The baseline of extensibility, we think should still be the requirement of a flag argument, especially when the syscall is moderately simple. And arguably, this is the case today. Though, as we've seen, there are quite a few syscalls without a flag argument that probably should have one. Read link add, I think, is the prime example. And while we're at it, the flag argument should be an unsigned int. And you should also go watch Florian Weimer's talk on Friday. He talks a bit about system call wrappers for glibc, and where he'll make similar points. And also will provide some hints for us kernel developers how we can make it easier for glibc to adopt new syscalls. I think the next one is yours, Alexa.
Yep. So this is effectively, there are a couple of ways already existing within the kernel to deal with extensions. If you want to add a new feature to some kernel API, if you want to extend it in some manner. And they all sort of have their own class of problems. So the most obvious one is just create a new syscall each time. The main problem with this is that it has an undue burden on user space, because user space now has to change each time you add a new kernel feature. You now have to get user space to adopt a new syscall, which then requires runtime checks to make sure the syscall is supported, as well as a whole variety of other things. Effectively, it's if you had to, imagine if you had syscalls where instead of having flag arguments every single time you wanted to add a new flag, you add a new syscall. It would be far too painful for user space to deal with. And this is especially true for shared libraries, and especially when you have seccomp as well, which you would have to update the filters each time you add new syscall, and it's a huge pain in the ass. And this is obviously, I would say, this is the other extreme. If you look at like ioctl style multiplexers, this is the other extreme view. Yes. It's the other extreme view, and I would say that going to extreme on either side, they both have pretty big problems, as well as the 64-bit flag argument issue that that was mentioned, because you can't pass 64-bit flag arguments as an argument to a syscall because of x86, 32, and a bunch of other things. And then another option is to add a new flag and then have a fun time with Vararg. So in other words, you have these variadic syscalls. The problem with this is that, first of all, glibc has had issues with this in the past, and in fact, Florian will say, and we have a thing about this. Variadic syscalls have their own quite painful thing in terms of usage for glibc, as well as they're pretty ugly to use. I mean, no matter how you design them, you have to like indicate whether or not a particular argument is being used, which becomes quite unwieldy if you have a lot of extensions added. Then the other option is, fixed size structs with enough quote unquote padding, which is, that's like the statics model, and a couple of other syscalls do this too. The problem with that is that you have to sort of be able to predict the future. Right? You have to say, well, I know exactly how much padding we'll need. And if you're going to sort of have to hedge your bets, you might as well have a design that allows you to be wrong in this prediction, not have to worry about it. And then obviously the easiest solution is just to get a time machine and skip extensions entirely and just design it right from the start. Unfortunately, we don't have this option. And also we have better uses for time machines than designing APIs.
Okay, switching to the next slide. So extensible structs, a modest compromise, we hope at least. Alexa mentioned this introduction of new syscalls can be a bit of a pain for user space. I think we can speak with some confidence to that. We're not just kernel developers, we're also Alexa maintains runc and a bunch of other stuff. I maintain lexc and lexd and a bunch of other stuff in user space. And these are very syscall heavy libraries. And I think because these are both container runtimes, they make use of basically of most of the syscalls that Linux has. And so every time a new syscall is introduced, it means we need to adapt to this new syscall, and we also need to test whether it is available and whether the feature is available. So the idea is that there should be some sort of compromise between having a dedicated syscall for everything and stuffing everything into a single syscalls. So full-blown multiplexer versus everything as separate syscall. And the idea was that extensible structs are a modest proposal and one step further from flag-based extensibility, but far away from ioctl madness. So if you look at this as a kind of scale, then you have creat, open@2, which is an extensible struct-based syscall, and then you're going into the full-blown type polymorph multiplexers range, PR-cuddle, and then finally you end up in the ioctl range, and then probably the only thing that's left is syscall or something. Why add more fuel to the fire? You could ask, why bringing up this discussion? Well, we have a bunch of APIs that can be expected to grow beyond just adding flags. And I think it would be nice if we had a better compromise between maintainability and simplicity, both for the kernel and for user space. I mean, the point is obviously we want to make sure that it's simple enough for the kernel, but also easier for user space to adapt to. Alexa?
Yeah, and so, and the other thing is that, as I mentioned, the alternatives to this are currently inconvenient. They all have their own pretty significant issues. Plus, at the very least, having this discussion will allow us to sort of deal with this fire here and now, and then we can document this properly, and we can have at least some form of consensus where we can say, this is basically what we think is the right way to do extensibility in general, and here are the guidelines, and that way we don't have to derail every single LKNL thread where there's a new syscall being designed with questions of, it depends who's there on the day determines what the actual API looks like. This is not ideal in my view, in our view, I guess.
Yep.
And this is mine too, yeah. So this is sort of a quick outline of what extensible structs look like. So OpenAT2 is the example here, but Clone 3, and there are a couple of other syscalls that look quite similar. The basic idea is that the syscall takes a structure, a pointer to a structure, and it takes a size argument. And the size argument indicates to the kernel what is the size of the structure in user space. So these structures can be appended to over time. And by following these couple of fairly simple rules, we can ensure both forwards and backwards compatibility with minimal pain for both user space and the kernel. So the rules are pretty simple. Any new fields to the struct have to be appended. And all of the fields, any new fields have to have the requirement that the 0 value of the field indicates that the old behavior, so the behavior of the syscall before the field is added should be followed. And then there are only 3 cases you have to worry about, right? So if k size is the in-kernel struct size and u size is the user space one, if k size and u size are the same, then you just use the struct verbatim. Both the kernel and user space are using the same struct, all good. If k size is bigger than u size, which means that the kernel is newer than user space, then you just use the u size bytes. So you copy the u size bytes of the struct, and then 0 fill everything else. And this is safe because any new features the kernel supports, the user space program doesn't know about because it uses the old u size, which means that filling them with zeros is safe because that just means don't use the new features. And then in the opposite case, if you have k size smaller than u size, so the kernel is older than the user space program, then what you do is that you copy the first k size bytes, and then, yep.
Can I briefly interject, Peter? The problem with the E2big arrow is that the extensible struct design sort of somewhat predates, we would have mentioned this later, but SCAD-set-adder and SCAD-get-adder and perf event open had this API already implemented. So did, I think, BPF, and they returned E2big to user space when this happened. So when we introduced the dedicated kernel API for this copy struct from user, we wanted to cover those callers as well and to have a consistent in-kernel API. And this is why E2big is returned. It's so big because we had the same reaction where we were like, this is really strange, but it's basically for historical reasons.
Yeah, though if you do squint at it a little bit.
That's really, really, really ridiculous when you start talking about actual file-based APIs like open. E2big is defined to mean file too big.
No. E2big is E2big is argument list too long is the description. You're thinking of I forgot what it's called, but there's another one that it's not the same. The
EM size or something
later. But E2 size or something like that. There is these are EF big. Yes, only one character different. Yes, but
it's
so if you squint
weird.
a little bit, it is weird. But if you squint, it does sort of make sense because you can consider the struct to be like a set of arguments. But I do agree that this would have been nicer if it was like an erno that is not used for other things. But it won't cause confusion for other error values. And then the third case is the forward compatibility one, which is basically old kernels can handle new programs because effectively, if you check that the trailing bytes that the kernel doesn't understand, if they're all 0, then it's safe to use because the user-based program isn't trying to use a new feature. And there is a dedicated kernel helper, as Christian mentioned, and this allows user space to make use of features opportunistically, basically. Without all the pain of having to deal with new syscalls and all the rest of it.
Okay. This is a point that we think might be worth bringing up. First of all, no more multiplexers, I think. This is more or less, I feel like, almost universally agreed upon at this point. And extensible structs are not intended to be multiplexers or used as multiplexers. They especially, I think, need to be discerned from multiplexers with polymorph types passed through a void pointer or a union or a long or something. PR-cuddle, obviously, ioctl, and ptrace, seccomp, or for example, BPF, because I'm mentioning this because BPF is a multiplexer that makes use of extensible structs or an extensible union, but it's not an extensible struct-based syscall because it has this command argument, so it is actually also a type polymorph multiplexer, and you can also look it up in the Git log commit history. It's explicitly introduced as such. So this is not an example for an extensible struct-based syscall, or a good one. And as I said, I think most people don't want to introduce any new type polymorph multiplexers. That seems almost universally agreed upon. glibc is also explicitly advising against the introduction of such new multiplexers because they're hard to deal with in shared libraries. Florian, again, will talk a little bit about this in his talk on Friday in his system call replis for glibc. Well, yeah, Arndt, you say that, absolutely agreed on no more multiplexers. The problem is they are still being proposed. They are still being proposed today. Like, I mean, for a couple of weeks or months, we had this idea that we introduce something that is called config FD. That would be a massive multiplexer that spans the new VFS API, and that is sort of any new syscall that uses an file descriptor to be configured was supposed to use this config FD API as well. And so far, this proposal has been ignored, but I think we really should nail this down and be like, this needs to be in the documents. Multiplexers, especially if they're type polymorph, should be completely necked.
Yeah, and I think a lot of us try to do that whenever we see them, but not every new syscall catches the eye of somebody who does.
Yeah, it should really be in the doc so that someone can respond to this and say, it's in the docs. We have agreed that we shouldn't do this anymore. I think I'm not stressing this. As I said, a bunch of people seem to agree with this. Okay, next slide. Alexa?
Yeah, so I'm just waiting to be able to see the slide. Well, this is the Vararg one, right?
Are you hanging? Am I hanging?
I don't know. Okay. Well, I can just go from memory. Yeah, basically, yeah. So I just want to quickly explicitly mention the Vararg style stuff again, because this was brought up, at least in all the discussions that I've had about extensible structs. I've seen this brought up again and again. So just to explain why Vararg has issues. So the first one is, as I mentioned, it's ugly to use because you would need to, especially for a syscall that doesn't have a command argument, like functal and prcuddle have, you would need to explicitly specify, like through a flag, whether or not to use the extra arguments. And if you actually imagine using this thing in user space, it would be quite painful. Like imagine if openat2 is the example, if openat had just been added like a new O flag to specify use the next argument, it would be pretty awful to use from user space's perspective. But even if we got past sort of the ugliness, it's still limited to 5 to 6 arguments depending on architecture. And glibc, and this is something that Florian mentioned to us, glibc actually has to call Vararg unconditionally because glibc can't be sure whether or not a syscall that currently exists, whether or not in a future version it will take more arguments. And so effectively what glibc has to do is that they call Vararg unconditionally on any variadic syscall and just pass garbage from the stack if there's no extra arguments, and just sort of hope that it all works out, which is pretty bad. And if you imagine that you do this to a syscall that glibc has not predicted this would be necessary to, then you would end up in, I mean, this already happened actually with otemp file, openat added a new case where the mode argument actually meant something. And as a result, you had a case where on certain distributions with a new kernel, otemp file would cause weird file modes because the file mode was garbage because glibc didn't pass anything. And this is sort of like a more generic problem of it's adapting APIs like this, in my view, is flawed.
So let's some syscall. Oh yeah, okay, Florian, go ahead.
There's just an inherent conflict here. So openat actually called Vararg conditionally. So it tried to do the right thing, and that is what broke otemp file.
Ah, okay, sorry.
We also have the option to do an ABI mismatch. Basically, have a prototype for the applications that says the function is variadic and implemented with an explicit argument list. But none of these options are really great. So please non-multiplexers in the future.
Yeah, ideally just avoid the problem altogether.
So Peter asked why a separate size argument instead of putting the size the first thing in the structure to make it feel less likely that it gets messed up. So we basically said you can do both if you want to, because I think setAttr does have the size as the first argument. And to me, it just felt nicer in terms of looking at the syscall. There is like, it feels more CE like. You have the struct and then you have the separate size argument, but it's not, if people really feel strongly about it, I think it's more, it's more about just deciding for one model.
I mean, I would say in my view, it's more that it's harder to get wrong if you have it explicit, because yeah, as Keith said, it's more fragile to include it in the struct. From the kernel side, you have to read this thing. You have to like read the first bit. But the other thing is that from the user space perspective, if user space forgets to fill this field, if they use designated initializers, then they could forget to fill the size field. It's much, at least from like a just writing code perspective, it's less hard to get wrong, I think. And also you have, yeah.
Yeah, the reason I'm saying that is because you can get real problems when you are passing a structure. If the structures pass around between different layers of user space that were built at different times, you have, you know, if you have an application passing a structure through library, the extensible structure in the library might be different from the extensible structure in the application. And now if you're not doing it correctly at every single stage, you're going to end up passing bad data to the kernel. It's kind of the if you're going to have a structure in memory, just kind of keep all the relevant information together. It seems counterintuitive, and I understand Arn's point, but you know, how many places in the kernel do we have, you know, multiple get users together? If your performance of that is really awful, you're going to have worse problems.
So it's actually not the performance issue on the double read, it's actually the confusion, because the kernel has a history at this boundary condition. That's where I'm looking at it as being important, is you're crossing the boundary from user space and kernel space, and confusion there is worse than confusion at the library and application layer. Like if the library and application get it wrong, it blows up. If you get it wrong at the kernel layer, you start confusing things, and you end up with, you know, privilege escalation bugs and things like that. There's a pretty common pattern of reading the size you want out of the structure first. You turn around and read it again, and now the size that you read the second time has changed because user space is racing you in an attempt to confuse you, and then the size is wrong in the structure that was copied out, and now suddenly the kernel will go operate on that structure and potentially read out of uninitialized memory, do all sorts of other things. So I'm in strong support of it being a distinct element and not in the structure.
And I would say that even with shared libraries, there are like, I see the argument that it's easier to not mess up in a shared library if it's part of the struct. But the thing is that there are still cases where you could mess it up. I mean, if you were to try to have an on-stack version of the struct, you run into the same issue. And at that point, the shared library would have to deal with the size anyway. They'd have to check that the size is right in any case.
But that applies if the structure is copied as opposed to being passed through pointer. And you're absolutely right, of course. I guess I don't really see Key's point about confusion, because to me the opposite seems to be true, because how many times have people used size of a pointer, and instead of using size of a structure? I mean, it doesn't seem to me that the confusion is any less or more.
Arguably, you could make the point that if somebody's starting to write a summary, you could make the point that glibc, the raw structs that we have them right now, because we're making very sure alignment issues and so on might not be the struct that glibc ends up exposing, and so glibc could arguably even decide they want to have this in a different format. I also wonder what glibc would prefer.
I think that we don't really have a strong opinion on this because I hope that we don't have to rewrite things before they go into the kernel. That would be basically a waste of everyone's time to write that code and maintain it.
But I think would it matter to you if, say, because I think both sides have drawbacks and advantages. Why not put it in the docs and say either put it in the struct, that's fine, we have precedent for that, or put it as a separate argument. You're free to choose the model. Would you care?
IO control has it encoded in the opcode, so that's what we've been using for a long time. So obviously that works. The larger concern is that what Peter mentioned is the size change and inconsistent libraries. People putting struct definitions into public headers and making it part of the library API, and then we change the definition for them, and things break because the offsets are not what they expected, because everything after that struct shifts. So that is.
If a program is built with an old version of the struct definition, it should.
Yeah, that applies to both cases equally. So
right.
if it doesn't really matter if the size is in the struct or not. And
we have in the first patch we sent to the list, we have mentioned that you can use both models, and I think that, in my opinion, is just fine because this is, as we see, a matter of preference.
I guess it also depends on whether that particular structure, whether that particular structure is likely to get passed around in user space or whether it's not. Because in some cases, the only reason for having the structure is to pass more than a handful of arguments to a syscall. You would never actually have an object of this that gets passed from one library function to another library function in a different library. In other cases, this would be the normal model. Like if you have the statx star thing, that is certainly something that you might pass around. But if you only have extra arguments, then no.
Okay, I think we should move on because otherwise.
Just a quick comment. The exception to passing around stuff is FFI libraries. So there you have, but usually you should be consistent at it.
Right. So one quick answer to Kay's point about check size, smaller page size. Yes, we originally had this in copy struct from user, but L rejected it with the argument that there is nothing inherently wrong with copying 2 gigabytes, 4 gigabytes from user space. So this is why we have it in each syscall. Okay. So,
but if we agree here that that shouldn't be the case, then we can always add it. I mean, there's no.
Somebody can send a patch for sure.
Yeah.
I don't feel like pushing on it. I really, that's not something I'm very concerned about. Copy from user extensible. Yes, please. When are we going to end up with C++? So on the theme of L, unfortunately, he's not around, I think. He raised the issue. He raised the issue that in the context of OpenET 2, that these extensible structs end up being a crap insertion, end up being a problem for inserting new features that we don't really care about. So sneak in problematic features without sufficient review while being forced to introduce a new syscall would be, that's the argument, would trigger a more thorough review. The barrier would be higher for getting the syscall in, and so we would catch those features earlier. We wanted to explicitly address this because I think this in my opinion, this doesn't really hold up. There are at least 4 counterpoints, in my opinion. I've raised them in other places as well. So for a start, features that prompted this reaction, they were all caught during review. Not our reaction, but other people's reaction. So there's doubt that this is even a real problem. And especially if you look at high-profile subsystems, such as the VFS or stuff that gets added to core kernel, there's usually a lot of review. And the problems, yeah. And so to the extent that this is a problem, it is not more of a problem, in our opinion, than with flags and other extension designs. So, and if you're a subsystem maintainer, then you should already be reviewing ABI/API changes enough to avoid this. And all this design essentially adds is the ability to easily add new fields to the struct. But I don't think the reason why we end up with this problem is that people try to sneak in patches through extensible structs. I think one of the main problems is features get snuck in when certain lists are omitted from these features being sent to, not just Linux API, but this also affects kernel internal subsystems where features get added that have kernel-wide impact, in my opinion. But there is no internal list where we coordinate around such things. So we don't see these features, we don't see these changes, and then at some point you end up with problems. But this is your slide, Alexa.
Yeah. And then getting back to just general review points, I mean, I would argue it's even debatable that syscalls actually prompt a more thorough review in general. I mean, it is the case that if someone puts syscall define, usually people do look at it. But I mean, if you take a look at some of the examples of more questionable APIs over recent years, and even more simple things like missing @flags, right? This is examples where I would argue it's sort of evidence that I think we just need generally more review all over the place, as opposed to this being a specific problem with extensible structs, right? I don't think that making every extension require new syscall would actually yield stronger reviews in sort of like these design aspects.
No, it doesn't. It doesn't, because people review what they care about.
And then to the specific examples that we're talking about here, all of the existing questionable features were actually they were implementable as just flags. So extensible structs in this context, it just so happens that OpenAT2 was the example where like this sort of started happening, where it's like, oh, well, clearly the problem is that this uses extensible structs. But actually, it's just that these things were just flags that happened to land right after we had extensible structs for some syscalls. So I think that these are two separate issues anyway. It's not really fair to blame it on extensible structs in this case.
Okay, so one thing we wanted to bring up also, because this is also something that affects glibc again and user space, is the ability to know what features are supported in a given syscall, and we now will just focus on extensible struct syscall. And the way this is usually done in user space is by having a painful, and I mean painful, trial and error approach. So we really have to write elaborate cosplay scenarios where we have to exercise the feature to see if it works without breaking the system. Emulation makes this even worse because emulated syscalls act strange. So for example, on WSL or what have you nowadays. And it's usually fine for long-running system daemons, but it often isn't usable for shared libraries or shorter running programs. If you want to see, for example, we make heavy use of new features in one of our code bases, and we need, when it's a daemon and when the daemon starts up, it needs to exercise a lot of syscalls, and basically we have written tiny programs that check if the kernel supports this feature, and it becomes costly, especially if you're a shared library. And we think it should be possible in a simpler and a saner way. And we have one approach we think might work with extensible syscalls, which is backward and forward compatible.
And I'll just say, just for shared libraries, the additional problem with shared libraries is that, like, if you want to test like certain things, you need to like spawn a program, and doing this in a way that doesn't affect the host process is like questionable correctness in general. But yeah, so this is the proposal that we have, and it's basically we discussed this. There was a mail list thread on libc alpha, as well as I talked about this earlier this year at LinuxConf.eu. Effectively, the idea is that we have a flag which indicates that a syscall should be a no-op. And what happens is that when you do this thing, the kernel then fills the struct that the user space passed with information about what features are supported. So the way that we propose to do this is effectively all of the valid flag bits and any flag fields in the struct are filled with the flag field set, which means that you could then, user space can just do a bit check to check whether or not that bit is supported. And then any non-flag fields are just filled with 0xFFF. In principle, you could use this to like implement range checks if you want to have if you have some sort of array that gets passed with the size in the struct. But that's like a more not so super important detail how you would do it. And then finally, user space, once they get this thing back, they look at the final structure to determine the feature support. And it's important to note that the syscall returns an error. This error should be unique for this case because you don't want to accidentally get you don't want to get confused between an error that is actually means something as opposed to this particular no-op case. Yeah, and then next slide. The next slide is basically the description of thing. Effectively, the copy rules are quite similar. The copy rules are quite similar to the original one. The only difference is that if the kernel is newer than user space, you just ignore anything the kernel supports because obviously the user space doesn't care about it. And if the user space is older, if the user space is newer, you just zero fill everything because we don't support any of these features. And there would be a new hypothetical struct to use a helper, and obviously the program on the side sort of describes what this would look like. Yeah, and I don't know if you're trolling or not, but this would be effectively a per syscall thing, right? And it would be, I think this is nicer than doing it by having a syscall that gives you information about every supported syscall, a supported extensible syscall in the system.
Yes. So I agree, it's nicer than a lot of the other options. It's just one of the things that we already said we would generally not do. So it's a little bit of violation of the rules, but it's also, I can see the upsides.
Yes. This was at least the way for us, the easiest way we came up with. If people have better ideas, then it's great. I think what isn't a great idea is because we toyed with this as well, I think this should probably be a per syscall thing.
I also had this discussion with Michael about landlock just before this meeting, before this session. We talked about how they do it. And what I said I didn't like there is that there's basically one syscall that allows you to probe what flags are possible for one other syscall.
Yeah,
that seems like overdoing it. What I would like is if there was a generic way to find out which flags are supported for any syscall. But that has complications because not every syscall has flags, and not every syscall that has flags uses them in the same way.
Right, but if this becomes a global, definition, that's the same way we have the syscall definitions sort of separated from the syscall implementations. That could be useful for all kinds of things. SecComp needs this as well for supporting this, as far as libsecomp, needs to be able to query it and see how large a given thing is. So that would avoid needing to add a SecComp specific syscall to gather that information.
Is there a reason you couldn't do it for each syscall? I guess.
So if the objection is not having it be a multiplexer.
Yeah, I mean that would be my objection. But I do see that it would be useful for SecComp, and yeah.
So I kind of like the idea of having it out of band because that would allow us to do it for all syscalls, including the ones that already have flags but might gain new flags, but without using the extensible syscalls infrastructure.
So something like this detect EA bit, which is a multiplexer. I'm joking.
It's not really a multiplexer.
It's not a multiplexer though, right? Because you send the argument of the syscall you want, and the size you can handle that you're getting written to.
Oh yeah, thanks for the 5-minute warning. let's circle back to this. I'm just going to wrap this up real quick. So we want to make this part of the kernel docs. This is the whole idea, so that we have the one true source. It's of questionable currency in the sense that it's not up to date. It's obviously a helpful document. I looked at this document when I did my first ever syscall. So our first attempt to update it went largely unnoticed. Reason was, and then John asked us to gather some more consensus, and this is why we did this session. And also in the meantime, we landed 2 of those syscalls. So our proposal is to update adding syscalls RST, formalize how extensible structs are intended to be used. Currently, a Perfume open is mentioned, but Clone 3, Open 2 are more modern and come with a dedicated API. We want to mention that new variable argument or type polymorph multiplexers are not encouraged or will not be accepted. You can tell me if you want stronger language or more moderate language. Mention syscalls with a flag argument for extensibility should use unsigned int, because right now we still see syscalls being sent to the mailing list that have unsigned long or long as a flag argument. And if you want to see why this is an issue, we recently had an issue with Clone 3 that the legacy clone syscall used unsigned long, and then you get sign extended on some systems, and suddenly if the higher bits become relevant in the kernel, you suddenly end up activating features that you never thought you'd be activating. You also want to describe some of the issues that the glibc folks or libc folks in general have, such as pointer types and structs and so on, as well as some C annoyances such as explicit padding and aligned fields. One thing I also wanted to bring up is that there is the possibility that some of these extensible argument struct syscalls could gain flags and structs are 64-bit. Yes, Florian.
Yes, and that's one of the arguments for having structs, right? Is that you can get more flag bits.
That's what we did. One thing I wanted to mention is we should probably make sure that we also have a sort of consensus at some point. This doesn't need to be in the docs right away. I think what we have right now is sensible enough. Is pointers to pointers, so second-level pointers in structs, which some people had strong reactions to. Understandable. IOVEC and so on are syscalls which have pointers to pointers. They are hard to handle for seccomp. This was one of the main reasons. But this is something we could discuss as well. Do we want to document that this should not be possible? You should not have pointers to pointers in extensible structs. Or would it make sense to allow it for specific reasons? And thank you, Ted. I think you showed 1 minute.
Yeah, the general point should be that we should better document what the actual standards are for syscalls, such that we can just point people to it. And also, I mean, speaking as someone as, I also looked at it for my first syscall. The advice there is not necessarily the advice to actually get an LKML, and so having these things be the same would be great.
So for the IO controls, we actually have the documented recommendation to use the U64 if you absolutely have to have a pointer, just because of the compat syscall story, so that then the kernel can read a 64-bit thing and turn it into a pointer.
Yeah, so you don't have different architectures thinking that point at different lengths. I mean, they are
aligned U64. Yeah, that's a debate as well. OpenApp 2, because Al wanted it, we used U64 for all arguments, I think, and for Clone 3 we used aligned U64 for all arguments. So not to do to end up with explicit padding where you have a U32 and then you pad with another U32 and so on. We just said I think this came from a discussion with Arn, where we basically said, just make every argument an aligned U64, and then user space can expose the type of struct that they want to expose.
Yeah, I don't know how much time we have left, but I wanted to mention that for the discussion about different ways that we can do syscall detection and feature detection, as Christian said, I mean, I would be happy with any solution for this, as long as it's something that will land effectively.
Yes.
Yeah. I mean, like, in theory, you could use BTF for some of this. You couldn't use it to detect flag bits. But, like, I mean, at least on the machine I'm on, BTF isn't enabled. And I think that as long as we have some solution that, like, allows us to do this, I'm sorry for bringing it up, Christian. But like the point is like anything, as long as it's possible, I'd be happy.
Yeah, I mean, this is something I think we need to come up with a solution. Thank you. Finishing the sentence. We need to come up with a solution that we can confidently land in a reasonable amount of time, because I think I would assume that Florian and the glibc folks would hold off on adapting some of those syscalls if they don't have a nice way of detecting new features. Am I right?
It depends. If it's very attractive, then we probably will use the baseline features anyway. It's more like what applications do when they expose it.
Yep.
And yeah.
Yeah, I think that's all of us.
Yeah, so we're just about out of time. I suspect there's a lot of discussion happening, so maybe this is something that should be taken to a hack room for people to brainstorm some more. I'm sorry we don't have more time, but I do want to give people a chance to take a bio break before our next talk at the top of the hour, which I believe is about Linux documentation. Thank you, Christian and Alexa.
Thanks for having us. Thanks for the good discussion.
Thanks.
Hey, Ted.
Yes.
Are you emceeing the full Kernel Summit track? If you are, that'd be great.
There was no one who was emceeing, so I stepped in. There was
okay.
yesterday, and I was very happy that someone was emceeing yesterday. But
Okay, Ron Minnick should have been there. Ron Minnick was there when I left before it started, but
yeah.
Okay. Can you do the next session? I was going to take
absolutely.
over. Great, because that way I can join the thing that they're wanting me to join instead of doing this. Thank you, sir. Have a great conference.
Yep. So it's just about 11 o'clock and we should get started. John, looks like you're ready. So yeah, I'd like to introduce Jonathan Corbett, who probably doesn't need any introduction to all of you. John is a master of making technical topics easy to understand, as demonstrated by his many Linux State of the Kernel talks. And he's also the maintainer of the documentation directory in the Linux kernel. And so, John, want to take it away?
Okay, thanks, Ted. Well, today my mission is to try to make documentation not entirely sleep-inducing. We'll see what we can do. I have various things that I can ramble on about, but I encourage people to pipe up anytime you have something to say or ask about documentation. I'd like this to be more of a discussion than me just sort of rambling away. But I can start with a simple little graph here. This is plotting in the documentation directory the number of plain text files that we have there against the number of restructured text files that we have. This does not include the device tree subdirectory, by the way. So we have been working on this conversion to restructured text over the last several years. And as you can see, this process has been going on to the point that for all practical purposes here, we have reached a victory point, and we can say that the conversion to restructured text is complete, in that pretty much all of the ordinary documentation has been converted over. A lot of that is due to a concerted effort by Mauro, who has been pushing through these conversions for the past few release cycles. And I'm grateful for that. We finally got there. You may see there's still several hundred what look like plain text files. A lot of those are make files or configuration files. There's still some source code example files, various things like that that don't actually convert readily. But for the most part, this particular period of churn that has been going on for years is basically done. And with any luck at all, I can stop explaining merge conflicts to Linus every merge window now, so we have less disruptive stuff going on. So in fact, with that work done, our job is done. Nothing more to do with documentation, right? We're pretty much there. Unfortunately, of course, that's not quite the case. There is still stuff to work on, so that's what I'm here to talk about, is where I would like to see documentation go from here now that we have some of this basic mechanical stuff taken care of. So something that I have been kind of harping on for a while now is organization and integration. The documentation subdirectory has long been just kind of a dumping ground where people put stuff and then forget about it. And we've had this massive unorganized directory of stuff there. What we have now is something that looks a little bit better, but we have a long way to go. If you go now to the front page of our documentation, and you look at this, you say, okay, this is actually pretty nice, right? We didn't used to have a nice looking front page like that for our doc. So we made some real progress. We have a bit of organization. But if you look more closely, you start to see, for example, over here in our main guide, we have a whole bunch of stuff that seems kind of tossed together. We start with the administrator's guide, we go straight to the build system, into firmware, more firmware, user space API. Then we get to our process documents, which perhaps should be something we do a little bit more towards the beginning of that. Various other things, we get down into faults injection and live patching, and then to driver implementation, and then locking. We have accounting between locking and block, that sort of stuff. It's clearly there's not been a lot of thought yet put into how we might present our documentation to people who are coming into it for the first time. Similarly, if you look at the actual page here, we get into, we of course talked about licensing first, because what's more important than licensing stuff. And then we have a bunch of essentially unrelated stuff that we call user-oriented. But again, there's not a lot of organization here. And this goes on for a while. So we get, into how to bisect a bug is one of the first things we present to our users. That sort of stuff. A lot of, again, seemingly unrelated stuff. And you think, okay, this is fine. I can work through this sort of stuff. But the other thing I would point out on this front page is that is the scroll bar. this goes on for a fair while. So if you want to try to find something here, you're going to be scrolling for a long time, trying to figure it out, because we've swept it into some slightly neater piles, but we still aren't really where I think we need to be if we want to have a user-friendly set of documents that can really help people get into both the use and the development of the kernel. So what we need is a nice set of organized manuals. What we have is still a pretty big collection of relatively unrelated stuff without a whole lot in the way of glue holding it together, without any real effort to try to turn it into a coherent whole. We now have the structure in terms of Sphinx and restructured text that should make it easier for us to do that. And in some parts of the kernel, some progress has been made towards doing that, but we have a long way to go there. So this is something that's pretty much at the top of my own list of things to do at this point. And I would love to have some help with people who would like to start to knit our documentation together and to make it something more coherent and more useful in a general sort of way. Beyond that, we use Sphinx and restructured text, but we do have our own dialect, and we've added some of our own stuff, including the kernel doc directive, which allows us to get documentation out of the kernel source itself. It's been a year or so now, where we made our version of Sphinx just detect a reference to a function like this and properly cross-link it, that sort of stuff, without having to put in special markup for it, which is something that's helped to stave off certain sorts of criticism that I'll get back to in the future. And we have a few other things, but I think there are other things that we could do if we really wanted to make Sphinx more useful for what we're doing here. There's a fair amount of things we could do, including, for example, a replacement for this C-type markup. This is a way that you can mark a specific structure type, for example, in a restructured text document. And it's useful in that it will generate a link in the HTML documents that will take you to the definition of that structure and the documentation of it. So if you're reading about the structure somewhere and you want to see it, you click on that. It works there. It helps to bring our documentation up forward into, say, the 1990s to have this sort of thing. But this sort of markup is also seen, and rightly so, as clutter in the plain text documents, where people don't want to have to stumble through this kind of thing. So if we could recognize the reference to struct foo and just automatically generate that link rather than having to put in the C type markup, that again would be a useful thing that would make the plain text documentation more accessible, which is something that is also important, while still giving us the features that Sphinx can bring us for other presentations like the HTML documentation. Similarly, we have the ability to cross-reference our documents now, which is really nice. So we have 3,000 documentation files. They're all still kind of silos. They're still each a thing unto itself. It'd be nice to tie them together more tightly. This can be done now, again, with Sphinx markup, but that clutters the plain text stuff, whereas we can simply recognize strings like this and generate them automatically. None of this stuff is all that hard to do, but somebody has to take the time to actually work on the documentation build system to do that. And volunteers to do that have been relatively scarce thus far. There's not too many people who want to work on this. It would be nice if we had a few more. This is a place where people who are not necessarily kernel developers, but who, for example, understand documentation, understand Python, could help contribute to the kernel and do us some real good here. I would love to see people who would like to help in this sort of area. So that's something we have to do. And then we have other little issues. All right. I added a slide and forgot to regenerate the PDF. Sorry about that. I got an email from Stephen Rothwell, the Linux Next maintainer, this very morning, saying that the documentation builds with the absolute newest version, the build breaks with the newest version of Sphinx, and wondering what to do. Sphinx has a lot of nice features. I like what its developers do, but they are not always really strongly focused on maintaining compatibility across their releases. And so whenever a new Sphinx release comes out, things break and we have to fix it. And nobody has yet fixed things for Sphinx 3.2. So I'm going to have to get to that, I suppose, as soon as I get a moment away from Plumbers and all of that. Anyway, so that's the slide you don't get to see. Moving on, we still have an issue with a lot of really ancient documentation. So this particular document, talking about Zen for the Itanium architecture, came to my mind recently when I had a developer trying to be helpful who was converting all these links to HTTPS links rather than HTTP, so that we don't have people trying to conduct man-in-the-middle attacks on versions of Zen. But if you look at this document, you see that this is talking about how you can get a Zen patch for the 2.6.18 kernel. This kernel was released in 2006. It's unlikely to be useful to us now, is a charitable way of putting it. And in fact, this link is broken entirely, but you can at least convert it to HTTPS and have it securely broken. Anyway, we have a lot of this kind of stuff in our documentation. In my mind, it really reduces the value of the documentation overall and will reduce people's confidence in it if the documents are full of spider webs and dust and stuff like this that is clearly not applicable and clearly not true. And I wish that we had more people who are interested in cleaning this stuff out, either updating it or simply deleting it, rather than just making tweaks around the edges, like changing the links to HTTPS. But this is harder work because you have to actually validate whether the document is still relevant in some way or not, do the work to update it. It's definitely harder work than simply changing the links or doing other sorts of things around the edges like that. But it's also more valuable to the kernel community as a whole, in my opinion, if people would do this. So I wish we would see more of that. The other thing that I wish we would see, quite frankly, is less resistance to simply deleting documents like this. We feel free to delete code that we think is not being used anymore. It's amazing how much resistance there can be to deleting old documents, because there might be something useful in it and somebody might want it someday. And so you really have to fight to get rid of this sort of stuff. And people get tired of that fight. I get tired of that fight. But I think that we should do it, because I don't think this kind of stuff really helps us all that much.
John, real
yes,
quick.
Steve.
Yes, I was wondering, for that type of solution, could we just make a archive or dead documents? So at least if it sounds like part of the problem is the fact that we have old documents that that's not useful anymore, and that could kill the credibility of the documentation if you're reading a bunch of stuff and say, hey, this is old, or you're reading it and then find out that it's not useful anymore. But if we have these documents, and maybe if people say it might be useful, if we just create like a archive directory and say, if you want to do any searching of what old documents are, maybe people will be less likely afraid to delete it if you just move it to this archive directory that you still have access. The problem with deleting it is it's really hard to search for files that's been deleted in Git. But if you have like just, and everyone just knows up front that these documents are outdated, but if you want to do some archaeology of Linux, go ahead, as long as we label it really well. I think that would give a little bit better credibility. What's your thoughts on that?
Well, Mauro did actually create a staging directory for documentation as kind of the last phase of his conversion, when he was running across the stuff that clearly nobody really cared about, but that he didn't want to just delete at that time. So we do have a directory for that. We're not really making much use of it, but we could use the documentation staging directory the way that we use the staging directory in general for other stuff that we intend to get rid of, and put stuff there for a couple of releases, and then get rid of it if nobody complains about it. It's a little bit harder with staging, with documentation, right? If you put code in the staging directory and you make it hard to configure in, then people are going to notice because something that they want just vanished on them. With documentation, of course, they don't notice until 3 years from now, and they go looking for something and say, oh, wasn't that there once upon a time? And it's long gone.
And this is why I argue for an archive, because documentation, it doesn't really, it's still going to take up space whether it's deleted or not, because it's in the Git history. But if it's just if you have an archive directory somewhere that we just move everything and forget about it, it doesn't get updated, doesn't get anything. It's just for historical reference, but still exists, easily to find. Maybe people will be less reluctant to removing document out of the main document source, just so it's easier to find. I guess that's the question. I guess.
Well, we could consider that, and I'm not necessarily opposed to the idea. I do wonder why it is different from code that we are quite happy to delete, even though it might in fact be useful someday too.
It's probably the same reason why I have a bookshelf full of books that are obsolete, but I will refuse to throw away. It's fun reading.
You haven't moved recently like I have, I can tell. Anyway, and there is other stuff, like Mike is talking about the kernel hacking guide, which is kind of fun. I mean, that was stuff that Rusty added many years ago. It's not so fun since they made him take all the profanity out of it, but there's still a lot of good stuff in there. And yeah, you hate to lose some of that. It's part of our history and such. Lucas said, talking about annotations, and we have added some warnings on some stuff, some Wikipedia type things saying, warning, this is ancient stuff, don't trust it. And we could also simply do more of that. I think that would be a useful thing to do for documents like this Zen document that I think if anybody actually tries to follow it, they're not going to be happy with the results that they get. The link to the kernel hacking guide, if you go to kernel.org/doc, you can read the documentation as a whole, and the kernel hacking guide is pretty easy to find from there. I don't have the link straight on my fingers right now, but it's not hard to find. Or you look in the documentation directory, you'll find it there as well. All right, a related thing, which again has to do with maintaining history as much as anything else, is something else that popped up, is there are a lot of links in our documentation. Links to a lot of places, some to like, vanity domains that developers set up for themselves, that sort of thing, various other things. And then people stopped maintaining that link in 2002 or whenever. They don't really want to keep it up anymore. And so the domain name goes idle. But spammers, it turns out, are rather more on top of keeping these domain names pointing to something. It's just that, to put it charitably, somehow I just got muted. Okay, I think I'm back. To put it charitably, the content that people put behind these links when they take them over is not kernel related. Let's just put it that way. So I really don't like to maintain links like that in our documentation. I don't want to send traffic that way. But what do we do? I mean, do we simply delete them? That, again, that deletes some history, that sort of thing. Do we put in a mark that says they're malicious and that you shouldn't follow them? Do we go through and replace them with Wayback Machine links where we can often get the original content that was there when somebody put that link in, that sort of thing. So we've had some discussion on that, but we haven't had any kind of consensus on the sort of thing like that. Ben is voting for the Wayback Machine, and I think that's good. That just takes somebody's time again to do that. And I would certainly be happy for patches that would update links in that way. If people wanted to do that, it's maybe the best solution, assuming the Wayback Machine doesn't then get sued off of the internet. But if anybody has other suggestions or patches working on that, I would be happy to adopt them. So the last topic that I want to talk about is a little bit different here. And that has to do, going back to the whole conversion over to Sphinx and all that, and a topic that I simply call resistance. So if you go through and you read discussions on documentation, here's a few quotes that I have grabbed from the last year or so from folks who have had things to say about this whole effort. and they have often used these sorts of comments to resist changes to the documentation, that sort of thing. I will point out that all these comments come from the same sort of person, or from the same person who doesn't appear to be in the room now, unfortunately. I will not name the person, although it's not that hard to figure it out if you want to search through these things.
He said there's another boss, or there's another thing going on right now, who he specifically said, good, I don't have to bitch about John's talk.
Well, that's yeah, maybe, but you know, I wish this person were here, because it becomes, it's a little hard to put a lot of work into this and to do stuff that I think is sort of useful. Doing stuff that isn't actually my paid work, right? This is not something anybody's paying me to do, to maintain the documentation tree. And then you run into this sort of stuff and people are calling it an absolute failure and threatening to vandalize it in the kernel tree. And this is the kind of thing that makes me think that maybe I don't really need to be working on kernel documentation, that I could pass this on to somebody else and take the time and go out and ride my bicycle instead, which might be a much more rewarding use of my time, that sort of thing. But, you know, the truth of the matter is I don't want to do that. I think that the work on the documentation is valuable. I think that if we can get to a point where we have better documentation in the kernel, I think that helps our developers do a better job of working on the kernel. I think that there's a lot of evidence that really good documentation is good for the inclusivity of your community as a whole. There are an awful lot of people who might find it find the community much more accessible if they have good documentation that starts.
John,
yes, Steve.
Just want to say, just to make you feel better, that same person also says the same thing about paravirtualization, modules, and SMP.
Yeah, I'm aware of that, but he doesn't threaten to delete them. Anyway, anyway, my point is that I would like to continue this. And what I would like to do is I would like to find a way to close this discussion. Right? We can talk all that we want to about how to make restructured text as unintrusive on the plain text reading experience as it can possibly be. And I am totally in favor of that. That was an objective that we all had from the very beginning, to do this. And we can work on making this better. But I really wish that we could find a way to end this discussion, because I don't want to have to deal with this anymore. So if we have any thoughts on how we can reach a consensus here and not have to fight this battle, I would be it would make my life a lot easier if nobody else. So I don't know if anybody has thoughts on that matter.
Well, I'll join it. Since I started the thread that one time, just because I hit that one example that was probably the poster child of what I have the issue with the plain text. It was two files with the same name. One was a txt file. The other one was a .rst. I had to jump in. I'm trying to learn a new subsystem. I jumped into the documentation file. I find reading the text files much easier because I could grep, search, do a lot more search for things, jump in things. I find plain text so much easier than going to websites or PDFs or whatever. Yeah, and I'm all for that. And I want to say first, John, I think you've done an excellent job. I think you've done a great job at this. But some things have as you even stated, that was kind of the poster child as well of how not to do things. And what happened was I read one document in .txt, the plain text, just reading it, and it was enjoyable. I understood everything. Everything was fine. And then I went to the RST file of the same name, but different aspects. And because of all the markup, I was rereading the same paragraph 6 times before I could understand what it was doing. And I realized that I can't read this. But if I put the markup on, it would be beautiful. And some people say, well, to get new people are not going to read plain text files. So I think we need the markup. I'm 100% in favor of markup. And there's been lots of places, all the ftrace code markup, I try to make sure is still readable perfectly. But I've not really been resistant to any of the RST conversions. I just think we just have to ingrain that these still need to be readable, because some people, I think they look at it and say, how can I make this look so beautiful from a PDF or HTML file, that they just neglect to make it look nice at all from the plain text point of view. And I think a lot of the issues is we need to really ingrain, like basically say, enforce somehow, I don't know how we can, to say, guys, make sure you could read it from plain text, and before you make these modifications. And I would be all, I think it's great. I love the fact that I could go and get a PDF if I have to or want to. And I think it's great that a bunch of new people prefer that. I'm all for that 100%. But like I said, when I'm learning a new subsystem, I'm going to grep for terms. I'm going to grep for things. I'm going to jump right into the documentation text files. And if they're not readable, it's useless for me. And I think that's kind of that's how I find documentation extremely important, especially when a current developer I was just talking to Bian a little while ago, saying that none of us know the whole kernel. So when we have to learn a new part of the kernel, documentation is where you go. And if we can't learn that new part of the kernel from the plain text, it kind of kills the use case. So I'm sorry I didn't mean to cause a war or battle war or something when I sent that email. I just was kind of like saying, guys, this needs to change.
Yeah, well, that was just one time that the issue came up. It was nothing new to me. And yeah, we do get some people who are very focused on making very pretty HTML and lose track of the readability of the plain text. And I often have to push back on that, and I have no problem doing that. That's fine. That's my job. I don't have any problem with that. I've seen a couple of people suggesting in the chat that you can get Sphinx to produce plain text from the markup stuff, and that's not an option for us in the kernel for a lot of reasons. The people who object to the Sphinx markup are going to object even more strongly to having to run Sphinx to get rid of it. Trust me, this would not fly. It's not something that I would try to propose. Among other things, Sphinx is not the fastest thing in the world, and they don't want to have to wait for it, and I get it. But also, they want to be able to use something like get grep and find everything related to something. And the run Sphinx to get plain text out first option would interfere with that as well. So that's not really an option for us. We have to keep the source documents in readable form.
I was wondering if there was some kind of technological solution, not Sphinx, because I've tried using Sphinx and it's painful to install because I have to like manually install a separate Python environment, yada, yada. And it's slow, as you pointed out. I was wondering if there was some kind of really, really fast, quick and dirty converter that maybe doesn't do a complete job, but strips out the more annoying markup, that either was a Emacs Lisp plugin or something that looked like a pager, like less or more, but does something that was super fast and maybe doesn't have 100% fidelity, but doesn't require installing and running Sphinx. Is that technologically even possible?
I believe it is. There was a suggestion for Pandoc in the comments, which is one way that might do that, although it may not fully understand our own RST tweaks. I don't think that would be that hard a thing to do if you wanted to do it. I will comment that installing Sphinx is pretty easy. Mauro made a nice script that's in the scripts directory that sets up a virtual environment and just does it all, and it's all nicely contained. It doesn't mess with your system as a whole. So that part should actually be easy, but you do still have to do it and wait for it to run.
And also, like I said, I guess what's the workflow for that? If you were to do a get grep, find your thing, then you have to run Sphinx or whatever utility on what you found to be able to read it. Too bad Git didn't have a script that could say, hey, Git, show me this, and it would actually convert it itself.
Add a git Sphinx command, yeah.
Someone might actually do that.
All right, well, I am pretty much at the end of what I had to say, so just sort of open up to any other sorts of things that people might have to say about the kernel documentation. if you have any comments or requests or such, we have a fair amount of time.
Well, I'm going to just read like what Tim Bird just talked about, how the last time he tried to do a doc fix, ended up spending a bunch of time fixing Maro's Sphinx install script and never ended up submitting the doc fix, which that is itself an issue. If you're not familiar with the markup language and you screw it up, and then you constantly try to, if you're fixing it, that might just turn off people who want to jump in and fix things. If the markup becomes a barrier. That's a new worry.
Yeah, we do get people who put in documentation changes that break the build, but it's pretty rare because restructured text is not that far from ordinary text, and if you stick with the formatting that's in the file now, you probably won't break things. And every now and then somebody does, and we go and we fix it. It's not that big a deal. I think honestly that restructured text is more of an aid and an encouragement for updating the documents than it is an impediment. But perhaps I'm wrong if other people have other impressions of that.
So one comment I would have is that it might be useful. So I've been caught by the same thing several times, which is the number of underscores to put under a heading. And maybe it'd be nice to have just a sanity check type script that checks for easy flaws to fix. I think you're right that most of the time RST, you do the right thing and RST kind of figures it out. But if there was a simple script, but again, that's just working around the fact that Sphinx is a pain to install. And I think as long as Maro's script is up to date and Sphinx, and that kind of glosses over the Sphinx pain, people should be, essentially compiling the documentation to make sure they're not breaking it. So.
Like a
anyway.
Sphinx edit, maybe, kind of like the cron edit and verse edit, whereas you have you bring it up into like a Vim document, and when you save it, it does a check to make sure it's a valid file, and it won't let you save unless it's actually valid.
Yeah, like we've got like check patches. You could have a check docs or something to check, and maybe I don't know. Maybe John has seen the pattern of the things that break the build, but. I've been caught by that dumb underscore thing like 3 times now. So
yeah, there are a few things, and I wonder if we could make a checker for a few specific things. I would add, if you have trouble with Mauro's Sphinx install script, just tell him, report it to him. He's pretty energetic at maintaining that, and is happy to install a virtual machine with any distribution you're running to fix it.
Oh yeah, he was very, very helpful, and when I submitted a patch for it and we worked through it, and so
the other thing we need to do, and I didn't mention it this time, although I should, is that the documentation build still generates vast numbers of warnings, and that is really pretty bad news because you don't see it if you've added a new one. So people have been working on reducing that number, but it's hard, and until we get to a warning-free build, in a way, it's a bit much to expect people to notice if they've added a new warning to the docs build. So I would love to see people working on fixing those up as well. That's a fairly urgent thing. In fact, I'm not quite sure why I took out my slide on that, but that's definitely something that people could work on if they want to help with the documentation. The question, how much do you need to understand Linux development and building to work on the documentation? Really almost zero for the purposes of the documentation itself. Obviously, if you're going to modify the documentation, then you have to make it more correct rather than less. And so you need to understand what you're talking about there. But for the documentation system itself, it's really pretty separate from the kernel's build system and the kernel build itself. Ben is asking about taking patches to the kernel doc comments. And that varies an awful lot depending on where the problem is. There are some subsystems that really don't want me doing that, and others that do. If you send them to me, I can always try to redirect the ones that might be problematic. I do take a fair number of those patches. but I get nervous about reaching around too far outside of the documentation tree, especially if it starts creating merge conflicts I have to explain to Linus. So I think in general, it's probably better if they go through the maintainer for the subsystem in general. But if you can't get help there, or if you have a lot of them in a lot of areas, I can entertain them as well. All right, well, if we don't have any other questions, that sort of thing, we can take a little bit of time off. I will thank you all for your attention and your comments, your discussion. Thorsten.
Yeah, there was one question I'd like to ask. You mentioned in the beginning the documentation is quite big, or what you see when you enter it. Do you have any idea how to split it up, kind of user documentation, developer documentation, and reference documentation, or what's on your mind in that regard, or no idea at all?
Well, we have actually already been doing quite a bit of that, right? We have now a user space API manual and a driver API manual, the core API manual, process, kernel process documentation. So work has been done in that direction. The effect so far has been to take one really big pile of stuff and to sweep it into a bunch of smaller piles, which is a step in the right direction. But there's a lot more work that could be done in that area still. But we are actually trying to do exactly that, to organize things, so that to organize things with the reader in mind rather than the kernel maintainer who has to maintain it in mind, which has been a struggle in its own right sometimes. But that I think we have had some success with. We just have a ways to go yet. All right, well, I thank you all very much. You all know where to find me if you have questions or patches for the documentation. And thanks to everybody who's worked to make the kernel documentation better.
Thanks, Jonathan. So we'll be taking a break until the top of the hour. And the next talk is restricted kernel address spaces. So enjoy the longish break, and we will see you in about 20 minutes or so.
Then I see you took over. I was going to put the break too. Ha.
Yeah, sorry, I was like in the middle of doing that, and all of a sudden the window disappeared, and it's like, oh, someone else grabbed it. And
Yeah, fighting over it.
Yeah.
Later.
Anna, are you on? And just going to confirm that Anna was taking over for emceeing the last two sessions. Yeah,
Probably on
guess
break.
not. I'll check in a bit. Okay. Yep. Cheers.
I am on, yeah. Sorry, had to get through the echo test and pause the Roomba.
Great. Thanks, Anna.
All right, so my clock says it's about the top of the hour, so I think we're gonna pick up again. Hope everyone had a good break. Our next talk is Restricted Kernel Address Spaces by Mike Rappaport. So Mike, whenever you're ready, take it away.
Thanks. Okay, I can click buttons, I see. Great. Okay, so it's been a couple of years now since since we started to discover hardware vulnerabilities caused by speculation in modern CPUs. It doesn't seem these vulnerabilities are going to disappear anytime soon, and even if chip vendors would fix their microarchitectures to cope with the possibility of speculation attacks, there still will be parts in field for several more years that are still vulnerable to Spectre meltdown and you name it. One of the mitigations for speculative attacks is a restriction of address space visible by certain context. For example, the mitigation for meltdown problem is a page table isolation that essentially makes user space code unaware of the kernel memory mappings. Another similar mitigations that's been worked on by Alexander Charter and independently by folks in Google, and there were two talks about it in this conference, is ASI for mitigations for L1TF in KVM. And in general, restricting address spaces, restricting kernel parts of the kernel to see less mappings, less physical memory, is a safe approach to take, and we're also exploring this in the context of Linux containers, and we're also looking into using restricted kernel address spaces to improve container security. Now there are already a couple of privileged mappings that exist in the kernel. For instance, if I uses its own page table to access firmware, and it's not exactly the same page table as normal kernel page table. We do have page table isolation already mentioned, and there have been several ongoing projects that try to use restricted kernel mappings for different purposes. First, I think I managed to map them chronologically. Probably it's not exactly the case, but it doesn't really matter. Anyway, there was a ASI work to mitigate L1TF and similar vulnerabilities with address space isolation. There was a proposal from Amazon a while ago to create what they called process local memory. We are actively pushing a patch that implements exclusive user mappings. And recently there was proposal from Intel to introduce KVM protected memory. So a bit of details about each proposal. As I said, ASI is intended as mitigation for L1, TF, MDS, and similar vulnerabilities without disabling the hyperthreading, and it's intended to prevent a sibling thread from spying on its other sibling. It creates a restricted page table for KVM usage. So the areas in white are excluded from the privileged code page tables as seen by parts of KVM. The process local memory proposed a variant of kmalloc and associated routines that would remap part of remap the allocated memory to a different virtual address than it was originally mapped by the direct map, excluded from direct map in the init and essentially all other page tables, and it was intended for storing, for example, vCPU state, VMCS, and things like that. The user exclusive mappings work similar to process local memory, but it suggests memory areas that are exclusive to a user. They are only mapped in user space page table and excluded from the direct map, so that only user space of the owning process can see those mappings. These mappings can be used for storing secrets like cryptography keys, and to another extreme, these areas can be widely increased and be used to store in the entire virtual machine memory. I think I jumped too far here. And the last proposal that was seen, I think, month and a half or so on the mailing list is to create a special type for VMAs. They called it KVM protected memory, so that the guest memory will be dropped from the kernel direct map, and it will be mapped only in the page table of the virtual machine, and the access from the hypervisor to the guest memory will be done in controlled areas of the kernel code using variants of get user pages. Now, as a variety of approaches, every approach has its own suggestion how to implement page tables, how to perform context switching, and how to do the state tracking. Particularly SI patches have a very significant part for implementation of entry and exit modifications to allow switching between default and the restricted kernel contexts. Since I mostly work on the MM parts in the kernel, I'm particularly interested in the requirements for the page table creation and management, and this talk is mostly about these topics. When I first started, and by the way, I thought about address space separation, a code name for the whole thing, but then when I did the acronyms for conversion of pointers between separated pointers and non-separated pointers, it was kind of against the code, so I decided to also use address space isolation. So as far as I can see it, what we need to manipulate restricted address spaces, what we need to manipulate the page tables, we need something that we already have, by the way, for the user space memory management. We need a method to clone the initial kernel page table for mappings for some range of virtual addresses, so that they will map the same physical pages. And we need the functions to add and remove mappings from that page tables. On purpose, I skipped types of the DST and the SRC because there are several things that can be done for them, and I'm going to talk about it on the next slide. So the source and destination, we can use directly PGD, PUD, and so on, and manipulate them directly like PTI does, for instance, these days. This approach is not very friendly to concurrent updates of the page table. If you take a look at PT allocation code, page table allocation code in memory, you'll see a lot of caution being taken not to allocate the same page, not to allocate pages for the same page table entry. And using directly page table primitives is not very friendly to tearing down the page table. Since PTI never does it, they didn't really bother about it. We also can use struct for the kernel page table other than the init it could work, but for me it created some cognitive dissonance because most of the struct is dedicated to user space memory management. It's VMAs, it's arbitraries, there's very lot of things that are not relevant to kernel page tables. And then when I looked into trying to implement PTI using struct to represent the kernel part of the page table, I've ended up with a function something like that gets destination and destination PGD, source and source PGD, rather than only having one source and one destination that actually abstracts the entire page table. So I've started to think, how can we add a new abstraction for the page table itself? Oops. This should have been one line. The idea is to extract fields that relate directly to the page table management from the struct to a new struct page table. This would be PGD, lock, accounting. I'll talk about PT context later a bit, and the CPU bit mask that represents CPUs that may may have this page table present on them. At the moment, this is a field in struct that says that allows excluding CPUs from running certain because currently is a page table. So this field will be also required for the page table abstraction. The conversion is relatively easy. We can use helpers like MMPGD, MMPGT to access a page table field of the struct for the existing code. Most of it can be automated using semantic patches. I didn't make it entirely automated, but I think people like Julia will be able to. And we also can have APIs that do actual work for the page table, and then simple wrappers that call these APIs for struct. For instance, it could be APIs that update counting on the memory allocated by the page tables. Another things, I really apologize, I didn't check the PDF before uploading it. In the source, it looked really neat. We need to ensure that all page table pages actually have, all struct pages representing page table pages have page table type set. This is important for proper tear down of the page tables, and then it's possible to use two unsigned longs that currently unused for page table struct pages. And whenever we need to access user space memory management struct, when we have only pointer to the page table that corresponds to it, we can always do something like container off and then call API that would deal with that requires the entire struct for that reason or another. And the last two things that I needed to complete the conversion is split some fields from context T to PT context T. I did it only for x86 for now, but it can be done, at least it looks like it can be done for other architectures as well. For some, it will be easier, for some, it will be harder. And then the context switching functionality for every architecture should be able to take page table instead of struct, and then the scheduler that is used to call switch with struct will have this helper function that inside calls the switching between page tables. The bit I've been stuck on for now is free in the restricted page tables, since first of all, it should be integrated with the existing MMU gather, and there were some pieces that explicitly dereferenced MM, and I got lost a bit there. And another thing that requires be very careful is to avoid killing mappings that are shared with the primary kernel page table. The plan is to use the empty unsigned longs in the struct page to help distinguishing page table pages allocated for the restricted address spaces and the original pages that are used by initial page table of init.mm. So the open issues, I still can say I have a good solution for them. It's more like hacks. First of all, page table type is not set for the entire page table. The parts of the page table that are allocated during the assembly or a bit later, times like setup arch, start kernel, are never marked as page table. They may also never make it to have a proper struct page because this memory may be reserved by the architecture, and it won't never initialize a memory map for it. There is some weird things about placing of CPU bitmap. From one side, it naturally belongs to page table because it says the kernel what CPUs are allowed to run to have their page table pointers to point to this page table. But at the moment, CPU bitmap is a dynamically allocated array, and as such, it placed in the end of struct. So if we place it in the end of page table, we must place page table in the end of struct, and this will break the randomization of the struct. We can get away with pointers, but I don't think it would be nice. So I can say I have something smart to say here. Feedback is welcome. And the context T, which is defined by each architecture, by many architectures, is sometimes a mix of things that architecture want to hook into struct, and sometimes these fields actually correspond to page table management. There is quite some research on properly extracting it and maybe adding another context to deal with part of it. The next thing I've been planning to do is to enable private memory allocations for the restricted contexts. The idea is to extend alloc page and kmalloc, kmem cache alloc with context awareness, so that objects that allocated with certain parameters will be placed in only in a restricted context and will be removed from other contexts. They won't be visible in the kernel direct map. There should be some special care for objects traversing context boundaries. For instance, when we're thinking about adding address spaces for network namespaces, SKBs usually traverse namespace boundaries, so we'll need to take care of SKB traversing address space boundaries in this case. I had some experiments with as I said, the address spaces for namespaces have implemented the GFP exclusive and the slab exclusive, respectively, for page allocator and for slab. And I used the exclusive slabs throughout network stack to allocate networking objects from the exclusive areas, and somehow I even was able to get traffic between namespaces or between the outside vault and the network namespace. Whenever an object is allocated to a restricted address space, it removed from the direct map using a direct map invalid, and when it is freed, it's restored into the direct map using set direct map default. These are APIs that currently implemented on 3 architectures, as far as I remember. There are similar APIs that implemented on PowerPC and S390, but they're called differently. And the last thing that required is the synchronization of all the restricted page tables whenever an object is excluded from them or re-added back. This can be done using shared entries at PUD level, for example, or with explicit synchronization points like vmalloc did, or even at the time of page fault. And to complete the picture of the restricted address spaces, I've been thinking of adding a new page type for the kernel pages, like we have page slab, page table. We have several bits that are still available, so we can have a new page type for page that belongs to a restricted address space. And for the restricted user mappings, we can have an anonymous mapping, anonymous inode in the way similar to what anonymous HugeTLB does, and then the pages that belong to that address space can be distinguished by page mapping pointer. Whatever we do, the restricted address spaces will cause a fragmentation of the direct map. And I apologize for ARM folks, they call it linear map. I still continue using x86 terminology. It's the direct map uses a second, third level leaf pages to map the physical memory. On x86 is 1 GB and 2 MB. So as much as possible, if we map physical memory with 1 GB pages, whenever there are no continuous chunks of 1 GB, they are filled with 2 megs, and when there are no continuous chunks of 2 megs, they're filled with 4K pages. Now, whenever we remove a page from the direct map, we essentially replace 1 GB page with 512 2 MB page, and a 2 MB page is replaced with 512 4K pages. So this causes performance degradation as the TLB pressure increases. We have more pages that TLB has to track, and we need something to mitigate the performance degradation, or at least make it not as severe as it could be. So we would like to have some mechanisms to keep as much as possible a direct map defragmented. One of the things that was proposed a while ago, and I didn't list it here, is to create a collapse of direct map pages in a way similar to THP. I think it's still being worked on. what we used with our exclusive user memory patch set, we create a local pool of 2 mega pages, and we also allow prelocation of large chunks at boot to accommodate requests of the exclusive pages from these pools and to avoid fragmentation of the direct mem. The prelocation approach is similar to booting kernel with mem equals x, and essentially excluding parts of the physical memory from kernel memory management. As far as I know, Amazon does this for virtual machine memory management, and I think Oracle also talked about similar things at the previous KVM forum. But if we do prelocation of large memory pools, we still have some level of control of that memory, and we still can access this memory from controlled points with a mechanism similar to get user pages or KMap. We also use local pool of smaller pages in our exclusive memory mappings implementation. So whenever a user requests 4K, we essentially allocate 2 megabytes into the pool, and this way we prevent the degradation of fragmentation of the direct map from 2 meg to 4K pages. And another idea we had is to add the awareness of the layout of the direct map to page allocators, to page allocator. And not sure if it's feasible from the complexity versus additional performance trade-off. It could be that complexity overweighs the added value. And after all the comments I've got about the fragmentation of the direct map, it made me curious to see what large pages in the direct map essentially mean. So first I did some archaeology research to find out when they were added, and the support for larger pages for Pentium CPU was added sometime in 1995. At that time, we didn't have strict requirement for commit messages to describe the changes. It just was 1.3.16, and well, Pentium could map 4 mega pages, so we just used it in the direct map back then. Quite similar addition of 1 gigabyte pages for AMD was also without description of performance benefits the usage of 1 gigabyte pages brought. So since I couldn't find any numbers in the mailing list archives, I've decided to measure it myself. I ran the benchmark on my T480 with a CPU, RAM, and everything. I've tried to pick the benchmarks that should stress the kernel parts of the TLB, and I've performed several tests. First of all, I used I degraded direct map first time to 2 mega for the entire direct map, and then I've also run the test with direct map that is using 4K pages for the entire mapping of the physical memory. I've run these tests on SSD and in TempFS, and I did the test with mitigations enabled and mitigations disabled. Mitigations like everything on and everything off. So these are the results, and as far as I could see, there is a difference, but I can't say it's a huge difference. maybe I couldn't find the right benchmark, maybe I didn't stress the entire system enough, but from what I've seen from my runs, it's not necessarily that on my CPU at least 1 giga pages are better than 2 mega pages. And it's not necessarily that 4K pages in the entire direct map cause severe direct map fragmentation, cause severe penalty for the direct map fragmentation. To conclude, overall using restricted address spaces and context is an improvement for security. It's not 100% mitigation in general. It could be mitigation for certain types of problems, but we still would raise a bar with addition of address space isolation to the Linux kernel. Reworking how we do management of the kernel page tables is a major challenge, and once we did it for user space, now we need to do it for the kernel itself. It won't be easy and it will take a time, I suppose. And the last uptake from this work is that direct map fragmentation, at least on my laptop, is not a real disaster. It has some downsides, but if you get improved security, it can be bearable at the very least. These are the links to patches I mentioned and to the history of the Linux kernel. This is my attempt to use a struct page table. It's a bit old, it's for 5.4, but somehow I got stuck in rebasing it on top of 5.8, so that's what I have at the moment. And the benchmark results are here if anyone wishes to look at it. Thank you very much, and I think we have plenty of time for questions and comments. I'll try to read the chat as well. Eric, there were I think even 3 presentations about this, doing this for KVM. We are in touch. I think Alexander is here as well. I don't know if Google guys, let me see, maybe. Yes, there are people from Google here as well. So up till now, Google didn't post anything publicly, so it's hard to tell what's going on there. We are in touch. We are in touch with them, and Alexander's patches mostly work on the updates in the context switching code. Here, Alexander, feel free to add.
Yeah, so I did something to try to encapsulate the
Alex?
Oh, sorry. That was. Can you hear me now?
Yes.
Yeah, that was another mute on my mic. Yeah. So what I did for in the context of ASI is try to encapsulate the page table. It's not as generic as what Mike is proposing, because that was only for x86 and very specific for ASI. So hopefully we can have something in common. And also, but so on x86 I worked out to do something for TLB. I think that's something you haven't done in your generic work. So if you're, I don't know if that's something you can reuse or you can have a look at it, but it may be specific to x86 too. And there is there is a lot of things we need to have and to discuss in common to have this generic way to manage the page table.
I didn't really understand the last question. What attempts can you try to rephrase, please, Ake? The benchmarks I did the benchmark to measure the effect of direct map fragmentation. I kind of took it to the extreme. I made the entire direct map use 4K pages, and I ran the same benchmark to see how much performance degradation or no would I get. So it wasn't that drastic. It's a couple of % for all the benchmarks I run. Some more, some less. Moreover, if I run the benchmark inside virtual machine, then the host direct map mapping doesn't matter at all. I get below standard deviation difference.
So, Mike, one other question. I saw you send different patch and RFC upstream. What is the status? Do you need some help on some of them, or is it
It's not
moving
RFC
over?
anymore, Alex. It's not RFC anymore. Well, the one I'm working on currently, the most actively, the exclusive user mappings. It's 500 line of code. So I don't know what is the status. Like, I didn't get much pushback, practically none. On the other side, I didn't get any AXO reviewed by, so it's somewhere in between.
Okay.
And it doesn't interfere with the general ASI. It's something relatively local anyway. Damian, just a second. It should be possible to download it directly from the BBB site, and if not, it is attached to the LPC main site contribution. The question is, are there any known performance drawbacks for the exclusive mappings? It makes some additional effort to allocate pages relatively to just doing mmap and going ahead. And plus, the pools of larger pages create some additional memory fragmentation. Not exactly fragmentation, it creates some additional underutilization of the memory. But the memory access remains entirely the same as you would access the normal mappings. Jonathan, the scale for benchmarks is a relative performance degradation, where 1 gig perform, I think 4K is 1, and the others are relatively to that. And Jonathan, if you'd like to, there is a link to the spreadsheet. You can draw bars whichever you'd like to. So if there is no more questions, I think we can get on to the break part.
Last call for questions. All right. See you all in 20 minutes.
Thanks, everybody. Bye.
All right, so welcome back, everyone. It's 1 o'clock, so we're going to get going. I'll turn it over to Satya now.
Thanks a lot. I guess I'll start. Does this? Okay, there we go. Okay, so hello everyone. I'm Satya Tangirala. I'm on the Android platform security team at Google, and I've been working on inline encryption and some features that build on top of it. So for the benefit of those who've never heard of inline encryption before, here's a brief intro to what inline encryption is and why we want to use it. So on the right here, we have the storage stack diagram, and inline encryption hardware sits logically right beside the storage hardware and can encrypt or decrypt data flowing through it and with some specified encryption algorithm and key. So in general, inline encryption hardware have a small number of programmable key slots, each of which can be dynamically programmed or reprogrammed with an encryption algorithm and a key at any time. So the way you'd use this hardware is to first program a key slot with the desired algorithm and key, and send a data request along with the index of the programmed key slot to the device. And the inline encryption hardware will then use the programmed algorithm and key in the specified key slot and encrypt or decrypt the data in the request appropriately. So note that this is very different from self-encrypting drives and TCG opal, since inline encryption hardware allow each individual data request to be encrypted with a different algorithm and key. So we want to use inline encryption hardware with Android because Android uses file-based encryption via FS script, where different files may be encrypted with different keys. And inline encryption hardware can be used to speed up this file-based encryption. All right, so some history about this project so far. So just before Linux Plumbers last year, I sent out V4 of the patch series, and I talked about the internal details of inline encryption back then, along with some extensions like device mapper support and how I thought we'd accomplish that back then. And over the course of the next few months, I sent out 10 more versions of the patch set, and V14 of the core patch series was what finally made it into the Linux tree. Now, the block layer patches were released with v5.8 of the kernel and the FS script, F2FS, ext4 patches, that is the file system patches, and the UFS driver patches went into v5.9. And this gave us essentially a full stack from a file system down to a device driver that was able to make use of inline encryption hardware. Now, as you expect, there have been many changes to the internal details from when I talked about them last year. And we've also implemented a few more features that build on top of the core patch series. And we've been carrying those extra features out of tree in the Android common kernels. And of course, we'd like to upstream these features as soon as possible, too. Now, it turned out that while there exists a UFS specification for inline encryption hardware, and that's what I coded my core UFS patches against, most real-life hardware that exists now require some quirks or some non-standard behavior to actually work properly, and wouldn't be able to function with just the core patch set alone. So a couple of patch series that are required to make some MediaTek chipsets and some Qualcomm chipsets, respectively, were also upstreamed, which truly gave us a full stack that was usable as is by anyone who had the appropriate hardware. Now, we've also been carrying, as I mentioned just now, we've also been carrying the inline encryption patches out of tree in the Android common kernels since November last year when I sent out V5 of the patch series, roughly. And we've been updating and maintaining the implementation there while I was sending out new versions of the patch series. And there were some lessons learned about how best to maintain all the inline encryption features out of tree while the core patch series was still being discussed upstream and modified. And we also recently sent out a patch series for direct IO support with FS script, which is still under discussion due to some objections on the restrictions that the patch series we proposed would have added. And I'll talk more about that later in this talk. All right, so inline encryption internal. So I'll give a quick rundown of the internal details of the core inline encryption patch series. Now, file systems submit struct bios down the stack to read or write data from disks. To greatly simplify it, a struct bio is essentially just describes a memory location, a sector on the disk, the size of the data transfer, and a transfer direction. So we introduce struct biocrypt CTX, and this struct can represent an encryption context, which is all the crypto information, like the encryption algorithm and the key that we need to encrypt or decrypt data. Now, each struct bio can have a pointer to a struct biocrypt CTX. We also introduce a struct block key slot manager, which acts as the interface to both check for the inline encryption hardware's capabilities and also to program key slots on the hardware. Now, each block device's request queue will have a struct block key slot manager, and it's the storage driver's responsibility to set up the key slot manager in the device's request queue with the appropriate inline encryption capabilities of the device. Now, a file system's job will just be to set an encryption context in a bio, and it doesn't need to worry about key slots at all. And it also doesn't need to worry about whether the underlying device actually supports an encryption in the particular encryption context that it's going to set or not, and we'll see why that's the case in just a bit. Now, the block layer will check whether the encryption context on a bio is supported by the underlying inline encryption hardware, and if it is supported, then the block layer won't do anything further. When block MQ gets the bio and creates a request containing that bio to pass down to the storage driver, it will first program the encryption context of the bio into a key slot in the inline encryption hardware using the key slot manager in the request queue. Now, the index of this key slot is stored with the request and is passed down the stack along with the request. So when the storage driver receives the request, it uses the index of the key slots stored with that request to tell the device which key slot to use for encryption or decryption of the data in that request. Right. So in the case that when the block layer checks if the crypt context is supported by the underlying inline encryption hardware, in this step, suppose it turns out that the hardware doesn't actually support the crypt context. Then the block layer will use the block crypto fallback to encrypt or decrypt the data in the bio. Now, the block crypto fallback was also part of the core patch series, and it uses the kernel crypto API to encrypt or decrypt the data in the bio. Now, the block crypto fallback may split a bio or clone a bio, and the split or clone is expected to be processed by the rest of the stack. And bio and IO must be called on the bio when on the clone of the bio when IO is completed. I messed something up. Okay, and the resulting bio that the block crypto fallback produces won't have any crypt context, and its IO pointer and BI private fields may have also been rewritten, and the original values of those fields will be saved before being overwritten, and they will be restored when the bio is ended, so that file systems won't see, upper layers using the block layer won't see any changes to this, to their private fields. And this allows the file systems to not have to worry about whether the crypt context they want to use is actually supported by the hardware or not, and file systems can just set an encryption context and let the block layer handle the bio however it sees fit. All right, so some differences from last year. So I'll briefly talk about the important differences in design from last year. So we have the stack diagram on the left from last year, and the stack diagram on the right is what's in upstream right now. And the biggest difference is that last year, the block layer was in charge of not just checking if the encryption context was supported by the hardware, but also for actually programming the encryption context for a bio into a key slot. Whereas this year, the block layer will only check whether the encryption context is supported and leave it to block MQ to program encryption context for each request into key slots. So key slots are now managed on a per request basis rather than on a per bio basis. And there have also been a number of improvements. The core inline encryption patch series now allows for more than just 8 bytes to specify the data unit number for encryption. And drivers are able to specify how many bytes they can accept for data unit number specification. Now, the block crypto fallback supports all the encryption algorithms that FSCrypt supports. And we also introduced the SB_inline crypt superblock option that file systems should set in their superblock if they want FSCrypt to attempt to use inline encryption with file contents on the file system. So one other issue that we discussed to some depth on the mailing list was how inline encryption would work together with biointegrity, also called protection information or PI in some contexts. The issue is that if we simply let the kernel use both features when they're present, the kernel will compute integrity metadata for the plaintext data, which is passed along with the plaintext data to the device. So the device will receive the integrity metadata of the plaintext. Now, however, if the hardware happens not to support inline encryption, then block crypto fallback will need to encrypt that data. And this encryption must happen after the integrity calculation so that the device again receives the integrity metadata of the plaintext so that the on-disk format remains the same whether or not block crypto fallback is used. But this would mean that the device will receive the ciphertext along with the integrity metadata of the plaintext, which will obviously not match because the integrity metadata was for the plaintext and that won't match the ciphertext. So one way to solve this problem would be to have devices that support both integrity and inline encryption to receive the integrity info of the plaintext and accept it, but then compute and store the integrity info of the ciphertext on disk instead. And we will also need block crypto fallback to encrypt data before integrity calculation if block crypto fallback ends up being used, so that when inline encryption is not supported by the device, it receives and stores the integrity metadata of the ciphertext along with the ciphertext itself. But this would require devices to do the correct thing, which is compute and store the integrity information of the ciphertext instead of just storing the plaintext that it receives. And we have no way of verifying whether they would do that or whether they do that right now, since there isn't actually any hardware out there that actually supports both these features yet. So, and then it's just, there's been discussions about it, but there isn't actually any hardware as far as I know. So the conclusion we reached back then when this was being upstreamed was that the safest thing to do for now would be to disallow inline encryption from being used with biointegrity. So if integrity support is declared in the request queue, any crypto requests will fall back to using block crypto fallback if it's enabled, and otherwise it will fail the I/O. Now, on the FSCrypt side of things, two new encryption policies at the IV number L block 64 and 32 are upstreamed. Now, these policies were introduced to optimize the use of inline encryption hardware, since reprogramming key slots too often can be expensive. So these encryption policies make it possible to use the same encryption key for multiple files while ensuring that the data unit number used to encrypt each data unit is unique and also fits into 64 or 32 bits respectively, and is not dependent on the physical sector number, since some file systems like F2FS may move encrypted blocks on the disk without first decrypting them. And next, maintaining these patches out of tree. So as I mentioned earlier, Android has had inline encryption since V4 of the patch series. And we've also had a bunch of features that build on top of the core inline encryption patches that we've been shipping in Android, such as metadata encryption using DM default key, hardware wrapped keys, direct IO support with FSCrypt, device mapper support, and eMMC support. Now, all these features were checked into the Android kernels before the core inline encryption patches were accepted upstream. And some of these features were, for example, first checked into the Android kernels back when the kernel had only V4 of the core inline encryption patch series. So keeping the Android kernel's inline encryption implementation up to date with what was being discussed upstream wasn't a trivial task, especially because it also required us to make all these new features compatible with what was being discussed upstream, and also because the core patch series touched many parts of the storage stack that were frequently being modified. So initially, my approach was to update the implementation by putting up a single diff patch that would contain the diff from the old version to the new version. But this ended up making it difficult for anyone not familiar with the code to merge upstream changes into the Android kernel, since there would be many merge conflicts with the inline encryption code. And reverting the inline encryption changes before merging from upstream was also difficult, because there were essentially now numerous patches about inline encryption scattered throughout the log that they would need to revert individually and try to hunt down and figure out how to revert them to, because of the way I updated the patch series. So it would have been a lot easier for others to revert all the inline encryption changes in case they were facing a difficult merge, had I always just committed a revert of all the old inline encryption code each time and then committed all the new inline encryption code. So that wraps up all the updates on what's been upstreamed already for inline encryption. Are there any questions so far about that part? Or any comments? I guess if not, I guess I'll just move on to the features that build on top of inline encryption that we hope to upstream as soon as possible. All right, so moving on to the new features that we'd like to upstream that we're still carrying out of Tree in Android. The first is upstreaming metadata encryption. So FScript only encrypts file contents. So the metadata in the file system is written in plain text if we don't do anything special. But we'd like to encrypt metadata as well. And we've had a device mapper target called DM default key to do this in Android for a few years now. And all DM default key does mostly is to set an encryption context on any bio that doesn't already have an encryption context set on it. So the data unit number it uses to encrypt any sector is simply the offset of the block from the start of the device. And this is almost enough to give us metadata encryption, if not for the minor detail that F2FS may sometimes relocate an encrypted file content block on disk without having the encryption key for that file. So F2FS needs to be able to tell DM default key to not automatically add an encryption context to certain BIOS. And for that purpose, we added a field called bi_skip DM default key to struct bio that F2FS sets to true. And when it's set to true, DM default key won't touch that bio. And this is pretty much a layering violation, and we'd like to figure out how to add metadata encryption in an upstreamable way. And one way of doing metadata encryption is to just do double encryption using, for example, dmcrypt on the entire device. And I'm calling this double encryption because encrypted file contents are going to be encrypted first by the file encryption key and then encrypted again by the metadata encryption key on that dmcrypt is using. And there's obviously performance concerns with encrypting things twice, and at least one of the encryption or decryption steps will have to be done by the kernel, since inline encryption hardware only encrypts or decrypts data once with one key, so it can only be used for one of those steps. And the other way of doing it would be to add metadata encryption support to file systems natively, and maybe refactoring some common metadata encryption code into FScript. Now, this has the downside of requiring updates to all the user space tools as well, like MKFS and FSCK. And I've taken a stab at this with F2FS, and I'll be trying to send out patches as soon as I iron out some bugs. But that's mostly the plan for upstreaming metadata encryption. The next thing in line is upstreaming eMMC support. So earlier this year, we came up with an approach to adding inline encryption support to eMMC, similar to the way we added it to UFS in the core patch series, and we put it into the Android common kernels. Now, what does complicate the picture somewhat, though, is that unlike for UFS, where there was an official JDEC specification that laid out how inline encryption would work in UFS, there is no officially released specification for eMMC inline encryption yet. There is, however, a specification for inline encryption that was proposed for the next release of the eMMC spec, and it's heavily influenced by the UFS inline encryption spec. But this spec only addresses hardware that supports the Command Queue Host Control Interface, or CQHCI, for eMMC, and there are some chipsets that have some form of inline encryption support that don't support CQHCI. So the patch series that we have for eMMC inline encryption support both the CQHCI spec as well as other custom driver-specific, inline encryption schemes. Now, unfortunately, we at an Android team don't yet have any hardware to test these patches ourselves, at least not on a recent mainline kernel that has eMMC inline encryption support. And we've been relying on vendors to test them out for us, and upstreaming these patches may take especially long because there isn't an official eMMC inline encryption spec yet, and because we don't have the hardware with eMMC inline encryption that can run a recent or upstream kernel. Moving on to the next thing, upstreaming device mapper support. So block crypto fallback will encrypt or decrypt a bio if the target device doesn't expose any crypto capabilities. So a device mapper device must expose its crypto capabilities somehow to tell the upper layers not to just fall back to block crypto fallback and to trust that it can handle inline encryption. So one way to do this would be to get a device mapper device to set up a fake key slot manager with a large enough number of key slots. And these key slots wouldn't actually mean anything, since the request submitted to the device mapper device would be cloned along with the encryption context and resubmitted to a lower layer device. And the block layer would program the encryption context into a key slot in the lower layer device's inline encryption hardware. So the number of key slots would need to be large enough so that requests aren't blocked waiting for key slots to free up while the block layer is trying to program key slots into the device mapper device's fake key slot manager. But allocating this large enough number of key slots that don't actually mean anything is just a waste of memory. So we first introduce a pass-through key slot manager that represents a key slot manager that doesn't actually have only a limited fixed number of key slots. Now, it still allows the device to expose its inline encryption capabilities to the upper layers, but it won't have any concept of programming key slots. So block MQ won't try to program a key slot into a pass-through key slot manager, and it'll just send the request through. A DM device can set up a pass-through key slot manager and expose the appropriate inline encryption capabilities based on its underlying devices without wasting memory on meaningless key slots. So there also exists inline encryption hardware that allow upper layers to pass them data requests along with the encryption key and algorithm itself, in contrast to traditional inline encryption hardware that requires the key and the algorithm to be first programmed into a key slot ahead of time. So these devices can also use the pass-through key slot manager in their request queues so that block MQ won't try to program the encryption contexts into any key slots, and will just let the driver handle the encryption context as it sees fit. So the question that remains is, what inline encryption capabilities should a DM device expose? So for now, we're exposing just the intersection of all the inline encryption capabilities of the underlying devices, because the block crypto fallback is only initialized when some user tries to use an encryption context that isn't declared to be supported by the device. And we have the restriction that the block crypto fallback SK ciphers must not be initialized in a data path. They need to be initialized out of time. So in our particular implementation, we are ignoring the case where someone might change the inline encryption capabilities of the DM device by just swapping out the DM table at runtime and we're leaving that issue unsupported for now, since it might require a significant amount of work for what we think is an unlikely use case. And lastly, I'm going to talk about upstreaming direct IO support with FScript. So in the upstream kernel today, any attempts to read or write FScript encrypted files with direct IO will fall back to buffered IO. And we want to change that, and it's in theory relatively straightforward to do with block crypto in place. Now we've sent out a couple of revisions for this in the hopes of getting it released in v5.9. But the patch series that we sent out would add the restriction that any user buffer must be data unit size aligned for direct I/O on encrypted files. And this is a change from the current alignment restrictions on direct I/O, which only requires that user buffers are aligned to the device's block size. And the additional restriction that this patch series would add was what was being objected to. So we do have patches that would work and allow block crypto fallback to work correctly without this restriction, but we would also need existing hardware to work correctly without that restriction. So we're currently waiting on testing from hardware vendors to confirm whether or not their hardware works without the restriction before figuring out how to proceed with that. All right, so are there any comments or questions about all these things or anything else, any discussion in general?
I guess if there's no questions, then we could all move on to a different session, since this was it for Kernel Summit.
All right, thanks everyone.